Hello students, I'm glad to bring this video on exponential distribution during this phase of lockdown. I hope all are in good health and actively learning through our online modules. Let us have a quick recap with the topics which was done before and continue. We started with random variables. Now random variables, we have two types. One is discrete random variable, the other one is continuous random variable. Under discrete random variable, there is binomial distribution and Poisson's distribution. And in continuous random variable, we have exponential distribution and normal distribution. Discrete random variable, this was done in our regular class. Binomial distribution, Poisson's distribution, continuous random variables. On these topics, we have already uploaded the videos. Now, this video is going to be on the exponential distribution. When we look into this mind map, it's very clear that exponential distribution comes under continuous random variable. We know that from continuous random variable, the necessary and sufficient condition for P of x to be probability density function is these two conditions. The first one is P of x greater than or equal to 0. Second one is when P of x gets integrated between the limits minus infinity to plus infinity, it should give us 1. Therefore, our exponential distribution should satisfy these two conditions, which we are going to see in our next slide. Okay. Exponential. So what is this exponential distribution function? When we make use of the word exponential, it is obvious that we use exponential function. So, like other distribution like binomial, Poisson's distribution function, here our exponential distribution function is defined as follows. The continuous probability distribution having probability density function P of x is equal to alpha into e to the power minus alpha x for x greater than 0. And for the rest of the values, it is 0. Is called exponential distribution function, where alpha is greater than 0 and x is called the exponential variate. Now, the function what we have over here, okay, so this function, it is only going to satisfy between the values 0 to infinity. It clearly says that x is greater than 0. So, when our limits are between 0 to infinity, then our function would be alpha into e to the power minus alpha x. Otherwise, so when we say otherwise, it's nothing but minus infinity less than x less than 0. So when we have limits between this, our function is going to be 0. Okay. Now, there's a small assignment for everyone. In this definition, it says probability density function. Now, probability density function, we have done it in continuous random variable. The previous slide is also on that. So, I want everyone to check whether this function satisfies PDF. That is, first thing, P of x should be greater than or equal to 0. Second condition is this P of x, when it gets integrated with respect to x between the limits minus infinity to plus infinity, it should give us 1. So knowing what is exponential distribution function, let us find out what would be mean and standard deviation of exponential distribution. Now, mean, we know what's the formula. which is nothing but minus integral x into p of x into dx between the limits minus infinity to plus infinity. Since we are working out for exponential, now it clearly says that only between 0 to infinity we can use this function. When it is between minus infinity to 0, it would be 0. So what are we doing over here? Let us split this integral minus infinity to plus infinity as minus infinity to 0, later 0 to infinity. Minus infinity to 0, it's very clear from our definition, it is 0. Now between the integral 0 to infinity, p of x is alpha into e to the power alpha x. Alpha is a constant. Let us take it outside and integrate. Using integration by parts, this would give us keep x as it is, e power minus alpha x divided by minus alpha. Now, differentiation of x is 1. Integrate this. It's going to be e power minus alpha x by alpha square between the limits 0 to infinity. Now, let us apply the limits to both the terms. When we apply the limits to the first term, this ends up with 0 into infinity or infinity into 0. Is that right? Which is nothing but an indeterminate form. When it is an indeterminate form, what are we going to do? Reduce it to 0 by 0 form or infinity by infinity form and apply L'Hospital's rule. So to reduce it to that form, let us shift e power minus alpha x to the denominator over here. Okay? And let us apply limit to the second term. E power minus infinity is 0 minus e power 0 is 1. So this is what we are going to have. Now what are we going to do here? To this, apply L'Hospital's rule. L'Hospital's rule is nothing but differentiate the numerator and the denominator separately. So when we differentiate the numerator and the denominator separately, numerator is going to be 1, denominator is going to be alpha into e power alpha x, and we end up with this. Apply the limits to this. Okay. So here e power infinity is infinity. 1 by infinity, this gives us 0. And second term, minus into minus is plus, which is 1 by alpha square. Is that okay? 1 by alpha square into alpha, which gets cancelled. And finally, our mean is equal to 1 divided by alpha. Moving on to the next is variance, which is defined as integral x square into p of x into dx between the limits minus infinity to plus infinity minus mean square. So if you people know the definition of this, the next steps, whatever we are going to be, we do would be same as what we had done for mean. Okay. So using integration by parts, this gives us the integral minus infinity to plus infinity. We split it up as minus infinity to 0. Is that okay? And 0 to infinity. And minus infinity to 0, we know that it is 0 for us. Yeah? So that is why you can just find in our next step, we just have the second term. We have directly written down that substitute for p of x, which is nothing but alpha into e power minus alpha x. Integrating, we end up with this. Now, like the previous derivation what we did, when you see the first and the second term, when we apply limits to those two, again it is indeterminate form, infinity into 0. So what are we going to do? Shift e power minus alpha x to the denominator. And to the third term, apply limits. Minus 2 by alpha cube is a constant. E power minus infinity is 0, upper limit, minus e power 0 is 1. So this is what we are going to have. So what's for the next step? Use L'Hospital's rule to this and to this. Differentiate the numerator and the denominator separately. Is this okay? Now apply the limits. When we apply the limits for the second term, we do get a value to this. But when we see with the first term, again, this ends up with indeterminate form. So continue with the process of L'Hospital's rule once again. Differentiate the numerator and the denominator separately. Clear? Now apply the limit to the first term. When that is done, we end up with this expression. First term is 0, second term is 0. We only have the third term 2 by alpha cube. Let us substitute for mean, that is 1 by alpha. Okay. So mean is 1 by alpha, whole thing to the power 2. Now alpha and alpha cube gets cancelled over here in the first term. Okay. Now this is the expression what we have. Finally, variance is equal to 1 divided by alpha whole square. So when we know variance, standard deviation, we know that it is given by square root of variance, which is nothing but 1 by alpha. So here, you people are supposed to know what is exponential distribution to solve the problems. What is mean? Mean is equal to 1 by alpha. Variance, which is equal to 1 by alpha whole square. Standard deviation, which is equal to 1 divided by alpha. So knowing this, let's move on to the problems over here. So this is the second problem what has been taken from the notes. The question goes on like this. The length of telephone conversation has been found to have the exponential distribution with mean 3 minutes. What is the probability that a call, first subdivision is lasting more than 10 minutes, second subdivision is takes between 3 to 5 minutes, third subdivision is it ends in less than 3 minutes. So from the given problem, it's very clear that it has to be solved by exponential. Even in your examination, continuous, there's nothing to break your head. They'll clearly tell you to solve it by normal distribution or to solve it by exponential distribution. But this problem has been considered purposefully so that you can know the difference between the binomial and exponential. We had a similar, I wouldn't say a similar problem. We had done a telephone problem in binomial distribution where the problem was on number of telephone lines. Therefore, the random variables what we had over there was 0, 1, 2, 3, if you people remember that. We used to count the lines, the telephone lines. But in this problem, here it talks about the duration of the telephone conversation where random variable takes the values between the given limits. Is that okay? When it says lasting more than 10 minutes, so it's more than 10 to infinity. When it is 10, we can have 10.1, 10.2, 10.3 up to infinity. where continuous random variable comes into consideration. Therefore, we solve this by exponential distribution. For the first step in any problem, when it comes to probability, do write down the random variable, that is x. So x in this problem is length of telephone conversation. Is that okay? Further, they have given us mean, which is nothing but 3. Mean formula we know that, which is nothing but 1 by alpha. Mean can also be written over here as 1 by alpha, which is equal to 3. Therefore, alpha is equal to 1 by 3. Now, we have to make use of exponential distribution. Probability function, this is how it is defined. Alpha into e power minus alpha x for x greater than 0. And for the rest of the values, a function is 0. Substitute over here. We have 1 by 3 because alpha is 1 by 3, e power minus x by 3 for x greater than 0, and for the rest of the values it is 0. The first subdivision question is probability lasting more than 10 minutes. So random variable probability of x, when I say x, it is nothing but length of the telephone conversation. More means greater, okay, than 10, which is equal to, greater than 10 means it will start from 10, goes on up to infinity. So 10 to infinity, it lies over here. Our function is 1 by 3 into e to the power minus x by 3. Substitute that. When we integrate and apply the limits, our value is 0.8773. Second one, it says to find out probability between 3 and 5 minutes. This is quite simple enough. So probability of random variable x lying between 3 to 5. Okay, we have 3 to 5. Again, it lies over here. So substitute this function in place of p of x, integrate this and apply the limits. And the solution is 0.1790. C, probability less than 3 minutes. So less than 3 minutes means this x is nothing but telephone conversation, length of telephone conversation which goes on with less than 3 minutes. So less than 3 means minus infinity to 3. So minus infinity to 3 means we write it as minus infinity to 3 over here. Now exponential, we know that from minus infinity to 0 it is not defined. So what are we doing? Split this. Minus infinity to 0 plus 0 to 3. So between minus infinity to 0, p of x is 0 for us. And between 0 to 3, substitute, integrate, apply the limits, and solution is 0.6321. Okay. Moving on to the second problem. So moving on to the next problem. This is the sixth problem from the notes what has been taken. It says that the sale per day in a shop is exponentially distributed with the average sale amounting to rupees 100 and net profit is 8%. Find the probability that the net profit exceeds rupees 30 on 2 consecutive days. So here the problem is very clear that we have to solve it by exponential distribution. The next thing what it says is average sale per day is rupees 100 and for that amount, the profit what is obtained is 8%. So for rupees 100, we do get a profit of rupees 8 on an average, that is for sale per day. Let us define our random variable x, which is given as, it's not given, we are considering this to be as turnover per day or sale per day. Is that okay? Next, mean is 100, which they've already given us. When mean is 100, we are supposed to find out what is alpha. So mean is nothing but 1 by alpha. So alpha is equal to 1 divided by 100. Let us substitute this in exponential distribution function. So P of x, which is equal to 1 by 100 e to the power minus x by 100 when x lies between 0 to infinity, and for the other values it's going to be 0. Now in this problem we are trying to find out probability for turnover. Is that okay? Finding out probability for a net profit. Finding out probability for a net profit would be same as finding out probability for a turnover. Clear? So here for a net profit of rupees 30, let us say our turnover is A. And they have told us that for the net profit of 8%, then the turnover is, it would be 8% into A, which is equal to 30. Therefore, our A over here is rupees 375. So what is this A? This A is the turnover what we have. Is that okay? If you have to get a profit of rupees 30, then our turnover should be rupees 375. So probability that profit exceeding rupees 30 means the sale what happens per day should exceed rupees 375. Exceed means it is greater than. We make use of exponential distribution. Integrate this function and apply the limits. This is what we are going to have. It talks about 2 consecutive days. Probability that the net profit exceeds rupees 30 on 2 consecutive days is given by first day and second day. So what are we doing over here? We are multiplying this. Now, we have just taken 2 problems. You can just try out with the other problems which is in the notes as well as the question bank problems. If you have any doubts regarding anything on this topic, you can feel free to ask us. Thank you.